What is the greatest possible area of a triangle with one side of length 7 and another side of length 10? And I encourage you to pause this video and try to think about it on your own. So let's just remind ourselves, let's just draw a triangle. Let's just draw a triangle right over here. Let's just draw a triangle right over here. And let's just remind ourselves what an area of this triangle would be. So if this length right over here, we call that B for our base, and that this right over here is our height, we know that the area of this triangle is going to be 1/2 times our base times our base times our height times our height. Now that we have that little bit of a review, let's think about this particular triangle. So let's say you have side length 10. We could orient it in different ways, but I'm just going to make that our base. And let's say you have the other side of length 7. The other side of length 7. And there's a bunch of ways that we could draw it. We could draw it like this. So let's say that is 7 right over there. I could draw it like this. I could draw it like this. That could be 7. I could draw it like this. I could draw it like this. This could be 7 as well. And let's just think a little bit about how would we maximize the area. So if we have this being our side of length 7, it's at this angle right over here. If it's at an acute angle, then our triangle is going to look like this. And if we're going to figure out our area, it's going to be 1/2 times 10, which is our base, times this height right over here, which is going to be less than 7. This thing right over here is going to be less than 7. The way that I've drawn it, 7 is my hypotenuse of this right triangle. This thing right over here is going to be less than the hypotenuse. The hypotenuse is always the longest side of a right triangle. So this altitude right over here is going to be less than 7. So as we increase the angle here, all the way up to here, what happens to our altitude? So if we increase this side over here, then our altitude increases even more. And we go all the way up to this point, then 7 becomes our altitude. 7 becomes our altitude. Here we have a triangle that looks like this, when 7 becomes our altitude. And then as we get angles above 90 degrees, as we essentially start having have an obtuse angle right over here, so a triangle like this right over here, then our altitude, once again, becomes less than 7. This would be our altitude. It sits outside of this triangle when it opens up, when it's an obtuse triangle right over here. But now our altitude is now less than 7 again. So the way to have the highest area is for all of these examples, the base is 10. We're not varying the base. So the area is going to be equal to 1/2 times 10 times 10 times the height, or times this altitude. And how do we maximize that? Well, we maximize it if the altitude itself is 7. For a triangle with side length 7, the way you maximize is if you actually form a right triangle where the sides are 10 and 7. If it's anything other than that, then the altitude, the height, becomes less than 7, and so you won't get your maximum area. So the maximum area is when your height is equal to 7. And so that's going to be 1/2 times 10 times 7. 1/2 times 70 is 35. So the maximum area you could have when one side has length 7 and another side has length 10 is 35 square units.